Just 1 minute.
Assalamualaikum, sir.
Walaikum assalam. How are you?
Sir, I'm fine. How are you?
You are fine. Okay, any doubt from last class?
No, sir, not from last.
Now, the last concept of this hydrostatics part is capillarity. Suppose in a particular capillary tube, which is immersed in a fluid, due to their interaction, the surface of or the meniscus of liquid in this tube will be of 3 different types. In first part, it may acquire this shape. In second part, it may acquire this. And third part, it may acquire this. So let me define you its mechanism. In first part, surface tension acts tangentially. So angle of contact in this case between this part will be theta, which is acute angle. So theta is acute. So adhesive force will be stronger as compared to cohesive force. So this adhesive force will tend to rise in level of liquid. So in this case, level of liquid in capillary tube get increases. In second part, these two are perpendicular to each other. So angle of contact in this case is 90 degree. Adhesive force, cohesive force becomes equal. So there will be no rise or fall in level of liquid. So level of liquid remains horizontal. So in this case, it remains same. In third part, tangential along this direction, tangential along this direction. So angle between these two parts, theta, in this case will be obtuse. So cohesive force will be stronger as compared to adhesive. So level of liquid will decreases or may fall. So this phenomena in which due to interaction of liquid from its wall of that tube, the rise or fall in level of liquid in this capillary tube is called capillarity. So capillarity is the rise or fall in level of liquid in capillary tube due to molecular interaction is called capillarity. Is it clear?
Yes, sir.
So we have to calculate how much level of liquid may rise or how much level of liquid may fall in the interaction between these terms. So in first part, meniscus of liquid is concave. In second part, meniscus of liquid is flat. In third part, meniscus of liquid is convex. So this will be in case of mercury. This will be in case of rose water in glass tube. And this will be a case of water in glass tube. Okay, just write it down.
Done.
Now for this part, we have to calculate Basin formula. Suppose in a vessel like this, if a capillary tube is inserted, like this, so level of liquid in this particular tube may rise due to its molecular interaction, or you'll say due to surface tension, let's say up to this level. So we have to calculate how much level of liquid is raised up in this particular capillary tube, let's say H. So we have to calculate the value of H, which is also known as Basin formula. So let me define you how to solve this part. Suppose this is capillary tube in which meniscus of liquid at its top point is behaving like this in the shape of a bubble. And we have about this much amount of liquid in it. Now it's at this particular junction, its meniscus would be in the shape of hemispherical ball like this. And there will be liquid at this point. Let's say this is radius r and this height will be also r. So volume of this segment will be pi r square, area of its base, times height h minus, this is behaving like a hemispherical bowl, this part. So 2 by 3 pi r cube. So if you subtract this whole term, you'll get 3 minus 2, that is pi r cube by 3. Is it clear, Ifra?
Yes, sir.
Okay. Now in this part, due to excess pressure in this concave side, which will applying some force on its downward segment of liquid to uplift it, and there will be downward force due to gravity. If these two forces becomes equal to one another, we can solve height of liquid raised in this particular tube. Or you can say there will be component of surface tension which must be acting in upward direction to withhold that segment of liquid. So let me define on the basis of concept of surface tension. Let's say surface tension is along this direction, T, inclined at some angle theta, so it will be theta. So there will be a component along this direction, T cos theta, which will be acting on the perimeter of top its ring. So at equilibrium, total force in upward direction must be equals to total force in downward direction. Upward force due to surface tension, T cos theta, acting over perimeter of that ring, that is 2 pi r, must equals to total downward force due to segment of liquid 1, which is of height h, that is pi r square h, times density. So this will give you mass of liquid times gravity plus, which is raised in this upper segment. So it will be rho pi r cube by 3 times gravity. So total upward force due to surface tension must equals to total downward force due to weight of liquid or acting on the weight of liquid due to gravity. We have just compared these two terms. Now on solving, you will get h equals to 2t cos theta divided by rho g r minus r by 3. Now this particular term is very small as compared to rest of the term, so we may neglect it. But in actual, the actual rise of level of liquid will be about this much. Is it clear?
Yes, sir.
Just write it down.
Done, sir.
Now, depending upon this relation, h is equals to 2t cos theta divided by rho g r, where r is the radius of capillary tube, rho is density, and g is gravity. On the basis of the value of theta, we may define its meniscus in three different parts. If theta is acute, it means less than 90 degree. So in this case, cos theta will be positive. So height will be positive. It means it will be ascending. In second part, if theta is 90 degree, cos 90 will be 0. So h will be 0. There will no rise or fall in level of liquid. So no change in level of liquid. In third part, if theta is greater than 90 degree, but less than 180 degree, so cos theta will be negative, so height will be negative. So there will be descent in level of liquid. Is it clear?
Yes, sir.
Okay. Now, next relation will be in terms of mass. We may write density equals to mass divided by volume, which will be equals to mass. Volume is pi r square into h. Put this term in the above expression, you will get h equals to 2t cos theta divided by rho, that is m by pi r square into h times g into r. R cancel out, h's cancel out. So you're left with m equals to 2 pi t cos theta divided by g whole multiplied by r. So in this part, mass will be directly proportional to the radius of that particular capillary tube. But in the above term, height is inversely proportional to radius of capillary tube. So just remember these two relations. In NEET, there was a question. A tube of radius r carrying a mass of 5 gram. How will mass be changed if radius of capillary tube is changed to 2r? So you'll say since mass is directly proportional to radius, so mass will also becomes double. So it will carry 10 gram. Okay?
Okay, sir.
Okay, just write it down.
Done, sir.
There was another question in NEET. If angle of contact is theta 1, theta 2, theta 3, how will height of liquid in capillary tube H1, H2, H3 be related? If
The
surface
H1
tension,
will be
H1 will be
largest and H3 will be smallest because height is directly proportional to cos theta and cos theta value decreases with the increase.
good. So in case of cos theta, if angle increases, the value of cos theta decreases. So on increasing theta, cos theta decreases, so height will decreases. So H1 will be maximum and H3 will be minimum. Since theta 1, theta 2, theta 3, so cos theta 1 will be greater as compared to cos theta 2 and will be greater as compared to cos theta 3. So H1 greater than H2 greater than H3. Now, related to this capillarity or Basin formula, you will be asked what will happen if capillary tube of insufficient length is immersed. Let me define you. Suppose you have a vessel like this carrying liquid up to this height, in which on inserting any capillary tube, let's say this, and now in this part, suppose another capillary tube of this much height. In first part, level of liquid is up to this point. So height of level of liquid in this part is about h. So what will happen if length of this particular capillary tube is less than h? Will the liquid overflow?
So it will overflow.
Your 4 marks will be deducted. You will get -5. Okay. Let me define you its mechanism behind it. According to the relation, h equals to 2t cos theta divided by rho g into r. So we are assuming a bubble like this, having center at this point, in which behavior of capillary tube is like this. Let's say this is radius of bubble and this is radius of capillary tube. So this is capital R, this is small r. So this inclination will be also theta. So cos theta equals to base by hypotenuse. So r is equals to, small r is equals to capital R into cos theta, we can write, or you may write cos theta divided by small r is equals to 1 by capital R. Is it clear?
Yes, sir.
If you put this particular term in this expression, you will get 2t divided by rho into g into r. Move this r to left side, so it will get r into h will be 2t divided by rho into g. T, surface tension, it will never change. Rho, density, it will never change. And g, gravity, it will never change. So you will say the product of height of level in this liquid and r, radius of bubble formed or meniscus, will be always constant. So if h increases, radius of bubble formed will decreases, and consequently if h decreases, radius of bubble formed will increases, and vice versa. Is it clear?
Yes, sir.
So in this case, suppose h is small as compared to its normal height. So the radius of bubble tries to increase itself up to its maximum part. Let's say h becomes 0. So what would be the value of r in this case? Put the value of
Then
h to be put the value of h to be 0 in this part and try to calculate the value of r. Let's say we have this h, move it to other side. So r will be equals to constant divided by h.
yes,
And you
sir.
have put at the value of h to be 0. So you'll get
Yes,
constant divided by 0, which is nothing but
yes, infinite.
good. So in this case, r will tend to become infinite like this. And if radius of a particular sphere becomes infinity, it will tend to become plane surface. Okay. Hence, meniscus of liquid becomes flat, but it will never tend to overflow. Is it clear?
Yes, sir.
Then let me define you why it is not overflowing. Suppose in this case, when meniscus of liquid becomes flat in this tube for insufficient height, so it will become like this. So if I ask you what will be the pressure difference between two different surfaces, in this
Okay.
case, 0. So in this case, at this point and this point, let's say 1 and 2, P1 and P2 becomes equal. So there will be no pressure difference, which is capable of raising up of liquid from that particular tube to overflow. Hence, level of liquid becomes flat and there will be no flow of liquid from beyond it. Is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
Any doubt related to this entire segment?
No, sir.
So we have just finished hydrostatics part, the study of fluid at rest. Next is hydrodynamics. In which first statement is Newton's law of viscosity. According to this, it says liquid in any particular medium, through any tube, through any canal, any river, anything, it always flows in layer by layer structure. Let's say this is one layer of liquid. Adjacent to it, another layer, and so on. Each layer will tend to oppose its neighboring layer and this viscous force will depend upon two factors. One, area of liquid film, this part, and since this viscous force will tend to change velocity of liquid, so this layer must be moving at some velocity v. So this layer will have velocity v plus dv. So there will be change in velocity between each layer of liquid, and there will be width of layer, let's say dy. So from this part, we may define a term. First, rate. Rate is nothing but change in any quantity with respect to time in physics. Change in any quantity with respect to time is called rate measure, and similarly, gradient, change in any quantity with respect to length is called gradient. So let me define you Newton's law of viscosity. According to this whole part, it says liquid always flow in layer by layer structure in which each layer opposes its neighboring by a force called viscous force, which is directly proportional to the area of liquid film and also to the velocity gradient. Ifra, is it clear?
Yes, sir, it is clear.
Okay, just write it down.
Done, sir.
Now, according to this relation, we may write viscous force is proportional to area of liquid film, and this is also proportional to velocity gradient. Velocity gradient, change in velocity divided by its width. So on rearranging, viscous force proportional to A dV by dy. Replace this particular proportionality sign by any constant term. So this viscous force will be equals to eta A dV by dy with some negative sign, since viscous force will be in opposing nature. Now this eta is called coefficient of viscosity. If you rearrange this particular equation to find its unit, its SI unit will be Pascal second, which is also called Poiseuille, represented by PL. CGS unit is poise. So 1 Pascal second is equals to 10 poise. Is it clear?
Yes, sir.
This eta will depend upon temperature as inversely proportional. Okay, just write it down to this part. Ifra, done?
Done, sir.
Okay. On the basis of the above part, there is a question. Suppose a box of negligible mass is placed over a layer of liquid, and this block, mass m, is hung along this path by any string. Find the value of m so that this entire system may tend to move at constant velocity. Find the value of m so that system will move at constant velocity of 20 centimeter per second if area of liquid film is 10 mm square, width of liquid is 0.1 mm, and coefficient of viscosity is 0.05 Pascal second. Take the value of gravity to be 10. Try to find the value of m. Ifra, which book you have for physics?
Sir, NCRT?
Any other reference book?
No.
So from where you prepare for NEET?
Sir, I have one book which is by Pradeep Kashripal. This is somewhat his name.
Okay, okay. उस बुक को देखकर डर नहीं लगता?
सर उसके नोट्स ज़्यादा बेटर लगते हैं उसमें, यानी कि जो न्यूमेरिकल के इम्पोर्टेंट पॉइंट्स होते हैं वो भी होते हैं।
कितनी मोटी बुक है वो। ओके, just use the above formula. We have force equals to eta a velocity by y. In place of force, which is nothing but viscous force, to overcome or compensate this force, there will be force of gravity which must be acting on this direction, which tends to move block along this way, and viscous force must be acting along this way. So these two forces will cancel out each other so that this entire system will tend to move at constant velocity. So replace this force by m times g. Okay, Fra?
Yes, sir.
And then try to find the value of m. Let me solve. M equals to eta, which is 0.05. Area of cross section 10 mm square. Velocity is 20 centimeter. Divide by value of gravity 10 and width of 0.1 into 10 to the power minus 3. So this part and this part will cancel out. 0.05 multiplied by this will give you 1. 0.1, 10. In numerator, we have 10 to the power 6 and 10 to the power 2, 10 to the power minus 8. And denominator, we have 10 to the power minus 3. So on moving to numerator, will give you plus 4. So on rearranging, you will get 10 to the power minus 4 kg. Ifra, is it clear?
Yes, sir. Yes, sir.
But according to your answer, it will be 10 to the power minus 2. Where you have done mistake.
Sir, I have done wrong conversion from millimeter to meter.
Okay, okay. Now, using this concept of viscosity, there will be a question on the basis of coefficient of friction, a coefficient of viscosity eta. According to the formula, F equals to eta A dV by dy. Just see this particular layer on which force is acting. So force must be tangential to it along this direction over this particular surface. So eta will be equals to force divided by A whole divided by dV by dy. Let me break this particular component. dV is velocity. We may write dx divided by dt multiplied by dy. This quantity will be nothing but change or shift in object towards horizontal direction with respect to length and vertical direction. Suppose you have a cube like this. So on applying any force tangential to this, there will be shift or change in its phase from this point to this point like this. Let's say this is x and this is actual length L. So the ratio of x by L is also called Ifra.
Okay.
It is the amount of deformed shape to the original shape, which is also called shear strain. Okay.
Yes, sir.
And the force which is acting tangential to this particular surface per unit area is also called shear stress.
Yes, sir.
So this quantity is shear strain divided by nothing but time. What we call it, change of a particular quantity with respect to time is also called
Rate.
So we can call it as strain rate. Is it clear?
Yes, sir.
So this particular ratio is also termed as shear stress divided by strain rate. Okay, just write it down.
Done, sir.
Now, using the concept of viscosity, we have to define types of flow in different segments. So next is types of flow of liquid. So we have mainly three different types of flow of liquid. First is, suppose you have a tube of varying cross-section area like this, in which each layer having same velocity v1 at any particular cross-section area a1. Similarly, at this instant, each layer must be moving at velocity v2 at some area a2. So this could be possible only if there is no viscosity. So liquid should be non-viscous. It should be incompressible, and it should be irrotational. Then this above criteria will be possible in this case. So this type of flow is called ideal flow, or which is called streamline. So this is ideal situation. Next is, suppose there is a tube in which middle layer will move maximum velocity and side layer, due to opposition by neighboring as well as wall of this particular tube, may get slower. So flow will be like this. This particular flow is called laminar flow. So in this part, there will be opposition between layer of liquid as well as due to wall of tube. So middle layer will move with maximum velocity and the edges layer will move with slowest velocity. Is it clear?
Yes, sir.
In third part, suppose there is irregularity in velocity of layer of liquid due to any obstacle in its path or due to any disturbance. Let's say there is obstacle in its path. So this layer, on striking this object, may get stopped. So a vacuum or a space created just after it. So the side layer liquid on reaching to this point may get enfold and form a circular shape, thus which is also called eddies formation. So this type of flow of liquid in which there is formation of eddies is called turbulent flow. Any doubt?
No, sir.
Okay, just write it down.
Done, sir. So your mic.
Okay. So if you have to define the flow of these different types of liquid, so we can assign some number, or let me define you a number which on the basis of which you may be able to define different types of flow in a particular tube, which is called Reynolds number. It defines the type of flow according to specific numerical value related with some physical quantity. According to this Reynolds number, if you have to calculate, suppose there is a tube having diameter d, in which we initially assume this liquid is to be non-viscous, incompressible, which is moving at some critical velocity Vc, so that the flow of this tube or the flow of liquid in this tube will be streamlined. Density of liquid and coefficient of viscosity. So first, let me define what do you mean by critical velocity. It says the velocity of liquid for which flow will be streamlined. Now, consider critical velocity depends upon density of liquid, rho, coefficient of viscosity, eta, and diameter of tube, d. Ifra, any doubt?
No, sir.
So let me calculate this particular relation using dimensional analysis. So we can write on the basis of their dependency, critical velocity is equals to some proportionality constant k, dependency over rho, eta, and diameter. So this dependency may be directly proportional, maybe inversely proportional, maybe some different exponential. So let me write x, y, z. So this will be generalized expression related to this critical velocity. So according to dimension analysis, write the dimension of left-hand term and right-hand term and try to compare the exponent of each part. So in left-hand side, we have velocity, which having dimension m0 L t raised to -1 is equals to k, which is proportionality constant. So it will be dimensionless quantity, neglected. Rho is density, mass divided by volume raised to x. Eta, ml -1 t -1 raised to y. and d diameter L to the power Z. So we can write m to the power x plus y, L to the power minus of 3x minus y plus z, and t raised to minus y. Ifra, is it clear?
Yes, sir.
Now, just try to compare the exponent of each part on left hand side and right hand side, and then try to find the value of x, y, and z. First, write it down, then try to
Okay,
find
sir.
the value of this.
Nothing is possible, boy. Possible.
Yes, Ifra? Try to find the value of z again. Rest is correct.
Okay, sir. Sir, 4.
Solve again. Let me solve on comparing the exponent. First, for m, x plus y equals to 0. Second, minus of 3x minus of y plus z equals to 1 and minus 6y equals to minus 1. So on solving, you will get y equals to plus 1. Put it in this first equation. X will be minus 1. Put these two terms in middle one. So minus of 3 minus 1 minus 1 plus z equals to 1. So minus minus plus minus 1 plus z equals to 1. So 3 minus 1 will be 2. So z is equals to 1 minus 2. So it will be minus 1. Ifra, is it clear?
Yes, sir. Yes, sir.
Now put these two values, the value of x, y, z in the above expression and replace k by Re. So Vc equals to Re root to the power x minus 1, eta to the power y plus 1, diameter to the power z, which is minus 1. So you may write Re eta divided by rho into d. Move these terms to left side to find the value of Re. So you'll get rho v d by eta. So this will be a final expression of Reynolds number, on the basis of which we may define its different types of flow. First is if Reynolds number is less than 1000, less than 2000, but greater than 1000, less than 3000, but greater than 2000, and Reynolds number greater than 3000. So in first part, it will be streamline, ideal situation. In second part, it will be laminar. And third part, it will be unstable between laminar and turbulent. And for greater than 3000, it will be turbulent. Ifra, is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
Okay. Any doubt related to this part?
No, sir.
Okay, just stop here for today. We will continue in next class. Okay.
Okay.